Let's take a look at number 4 from the same assignment. You can see here that we have a baseball situation. I've added this right triangle here because I want to show you where we come up with the horizontal and vertical portions of the ball's path. So what I'm going to do is say, all right, so the ball is traveling at 130 feet per second. So I'm going to go ahead and put this over here, 130, and I'm going to call it 130 t because that would be 130 times the number of seconds feet. Now, as we know, that's not actually the path of a baseball or any other item because gravity will win this battle. So it's not going to be a linear pathway. It's going to be a parabola, and eventually that ball will come back and hit the ground. Now, here are the other things we know about this. The ball's hit at a 30-degree angle. So when we think about it, if we call this our y portion and this our x portion, these are our initial velocities. So if I want to find x, I'd use the cosine function. Cosine of 30 degrees is equal to x divided by 130t. So x then would equal 130t cosine 30 degrees. By the same token, I know that the sine of 30 degrees would be y over 130t. So y would be 130t cosine 30 degrees. Those aren't exactly our parametric equations. We're close, but we have something else we haven't considered yet, and that is the whole gravity situation. This is simply the initial velocity. All right, so here's how we find actual velocity. It would look like this. It's y equals, and we have to include gravity. So in this case, we're in feet, so we're going to do negative 16t squared plus initial velocity, and I'm just going to call that v sub o, times t plus the original height, h sub o. So v sub o represents the initial velocity, h sub o is the original height. Now let's go ahead and plug the numbers for this situation in. Again, that's only for the y values. The x values, pretty simple. 130t cosine 30 degrees. Now here's where I have to start using the gravity situation. So negative 16t squared takes care of gravity. The initial velocity we found to be 130t cosine 30 degrees. But there's one more situation, and that is the ball's hit 4 feet above the ground. So we have to do a plus 4 at the end. One thing that's good for us is the fence is a much easier calculation. The fence's distance away from where we begin is 350. The height is 30, but again, if I want to actually see that fence, I'm going to subtract something like maybe a 2t, and that should give me a pretty decent view of the fence other than just a point only. All right. As I was entering my calculator info, I realized I made a fairly significant mistake on my equation where it said cosine of 30 right here and right here. That should most definitely be sine. I guess I was in a little bit too much of a rush. It happens to the best of us, and sometimes it happens to me too. All right, so let's take a look at this. I have gone ahead and entered x1, y1, x2, and y2. And now I want to take a look at the graph. However, I got to think about dimensions here, about the window situation. So 0 to 7 may be just fine. I don't think the ball's going to be in the air more than 7 seconds, so we can live with that. The X max, though, is an issue. I know I need to go past 350 because the fence is 350 feet away, so I'm going to go up to 400. The Y minimum, 0 is fine, but I probably want to go higher than 5. I'm going to do like 100. It really isn't hugely important, but it may help me get a better view of the situation. So let's take a look. All right, there's the flight of the ball, and there's that fence. And what do you know? It has cleared the fence. Clearly, the ball is over the fence. So that's answering the first question. Yes, it has cleared the fence. But now we need to start the process of finding out, well, by how much. So what I'm going to do is trace the pathway of the baseball until I get to 300 feet. Excuse me, 350 feet. Now you can see right here at 3.1, I'm at 349. At 3.2, I'm at 360. So I know it's somewhere between 3.1 and 3.2 seconds. However, I need to get more accurate than that. I want to be accurate to the nearest hundredth of a second. So what I'm going to do in this case is I'm going to go back to the window. We know I'm between 3.1 and 3.2, which means I'm going to change my t-step. I want to make the t-step smaller. I can gain accuracy by narrowing down how far we're looking around on this graph, and it should graph pretty quickly for us still. All right, that looks good. So let's go to trace, and what I'm looking to see is when are we really close to 350 on the X value. Oh, we're right there. So what I look at is at 3.1, I'm a little below 350. At 3.11, I'm a little above. I'm going to take the value that's closer to 350, and that is at 3.11 seconds. So the answer to the question is yes, the ball clears the fence, and it's by approximately 21.4 feet. Now I'm getting that because I can see the Y value is 51.4 at that point. All right, for the last problem we're going to look at number 6, Nancy hitting a golf ball. Now we're given some initial situations as far as she's hitting the ball at 180 feet per second. And we know that it's also for part A at an angle of 15 degrees. Now this is somewhat related to the baseball question. So what I'm going to do is look at it this way. I know that the X value here is going to be just the cosine portion of this. So we're going to do 180t times the cosine of my angle, which is in this case 15 degrees. Now y equals, now this vertical component has to consider gravity, so negative 16t squared plus the initial velocity, this is the vertical velocity, so it's 180t times the sine of 15 degrees. And then we also have to add in the initial height of the golf ball. Well, we're assuming it's being hit off the ground. Maybe that requires a little golf knowledge, but we're going to just go with 0. All right, now I've actually already punched in this equation right here, 180t cosine of 15 on x1, and then on y1 I've got negative 16t squared plus 180t sine of 15. Now we need to talk about the window. I still have window settings from the last problem. Those are no good here. How long is the golf ball going to be in the air? I mean, it can't be very long, right? So I'm going to go like 0 to 10. And if I need to, I'll adjust that. But I'm going to set the t-step as 0.1. The X-max is also another issue. Remember, this is measured in feet, so we have to decide how many feet can we hit the golf ball. I'm going to go 600. That would be 200 yards. And again, there are people that can hit it further than that. And if that's what happens in this scenario, we will adjust. The Y value, Y max of 100, again, I have no idea how high this ball is going to go. 15-degree angle's not real sharp, so we might be fine. Let's go ahead and look at the graph. Oh, that's lovely. Take a look at it. All right, now our job here is to find out how far the ball, or how far down the fairway does the ball hit the ground. Okay, so one thing I need to do is actually go back to that window. I know it seems kind of silly, but I need to see less than 0 for the Y minimum. I'm going to go like negative 10 so I can actually see the ground level, because what I've got to find is where does that ball cross the ground. In other words, obviously it's not going to cross the ground, but where does it hit the ground? And so right here I'm at 5 feet. That's at 2.8 seconds. I'm at about a half a foot at 2.9. At 3, I've gone below 0. So in other words, at this point the ball's hit the ground and now it's bouncing or rolling. So I'm going to go back to my window settings. We know it's between 2.9 and 3 seconds. And I'm going to start narrowing things down. So 2.9 to 3, and we'll change the t-step to 0.01. And let's take a look at what that graph looks like. Okay, and if I trace, again, remember I'm looking to see when I'm really close to 0, and I get there pretty quickly. So I have to decide between 2.92 seconds and 2.91. Well, at 2.91, I'm closer to the ground, so I'm going to go with that. At 2.91 seconds, The ball has traveled about 505.95 feet. All right, part B, there's only one thing that's going to change, and I think you can see what that is. It's the angle. All right, so I'm going to let you guys do part B. All the solutions are available to you on my website. Have a lovely day.